In this unit, we're going to be talking about some data structures that hold multiple values. They're going to be arrays and lists. And before we do that, we need to talk about different kinds of variables. We talked about this a little bit in Java. In C#, the .NET framework, all data types fall into two categories. They're either value types or they're reference types. So a regular variable that holds a value. So if you think about when you declare an int called mynum, okay, what happens is the compiler goes out and sets aside a piece of memory, okay, and for int, that's a 32-bit data type. So 32 bits. Let's pull up the calculator here. 2 x to the y 32. An integer can hold a number up to 4,294,967,296 different numbers. It uses half of those for positive numbers and the other half for negative numbers, plus you have 0 in there. But it's a 32-bit number, and that's why we have a limit on that. But so when we declare an int, and this int's called mynum, it's actually going to set aside, the compiler is going to set aside 32 bits to hold the number that we put in there. Okay, and it holds it directly in this location. Okay, so that's regular data types. Doubles work the same way. Strings in C# are value types. Okay, they're not objects like they were in Java. We talked about that in Java. We had to do some special things when we compared strings in Java because they were objects, and how we compared them was pretty important. So strings are actually considered value types in C#. So let's talk about reference types. What's different when I declare a variable that's going to hold an object? All right, so let's think about back to Greenfoot programming. We would declare a crab, and maybe we called it my crab. Okay. And then we had to create the object by calling its constructor. All right, let me put a line between these two. So what happens here? A crab, what's its size? We don't know. We can figure. We could take the time to figure it out. You know, it had a bunch of fields. You know, it held ints. It held strings in fields. It had some methods that took up some space. Okay, so however big that crab is, the compiler is still going to set aside a good chunk of memory to hold that crab. But when we declare my crab, it actually sets aside a piece of memory to hold the address of the crab that we created. And that address points to or refers to the memory location where our crab object is stored. So rather than holding it directly here, it does the reference pointing to the place where it is stored. Okay, so that's a little bit different. We have to create the object first and declare the variable, and we assign the object we create to the variable. Okay, and it stores a reference to the object in memory. So they're stored in two different ways. To further illustrate that, let's do maybe my number, we're storing the value 8 in my number. Okay, so it would actually hold 0000000 32 bits up until 100 1 2 4 8. So total of 32 bits with a 1 in the 8 spot. It actually holds the data. This one, the data is kept somewhere else, and our variable points to the data. It's important to understand those differences as we get into these arrays, which are objects, and lists that we'll be talking about later that are objects.